All right, so today we're going to be graphing simple rational functions. So to graph a simple rational function, it's going to have the form where it's just like one x on bottom, there's no x on top, so it's just a number on top, and then you could add or subtract something on the outside if you would like. So that's type 1. Type 2 is just an x over an x. So the rules that we learned for the asymptotes are still going to apply here. I'm just going to show you how to do it. So we're going to first graph type 1 here. So it tells us that our vertical asymptote is always x equals h, and that's because that's what makes the bottom equals 0. Your horizontal is k because the bottom is bigger, so we'd have y equals 0, but then we're adding a number to it, so that's why it ends up giving you that k. A is just going to affect your shape, if it's like wide, skinny, and which quadrants it goes in stuff. You could pick a point and check to make sure that you have it in the right stuff. This is an example where domain that your range this time will be all numbers except the asymptote. So the domain, remember from yesterday, it was all real numbers except the vertical asymptote. So range, you're going to say all except the horizontal. So number 1 to graph. So I'm going to say my vertical asymptote is at 1 because it's that number opposite of that. Horizontal asymptote is your outside number, so that's a 2. And then the 3. So I'm going to put it up here. So if it is positive, it's going to go in these 2 quadrants, and if A is negative, so this is about our A is going to go in those 2 quadrants. So it's a little trick. It only works for this one simple type right here. So if we graph those, see, I'm going to graph my vertical, and then there's my horizontal. And you see how 2 new quadrants happen? Since 3 is positive, we're going to make them follow the positive dotted lines. Don't make it hit the dotted line like me. That was an oopsie there. It follows them. So number 2, my vertical asymptote is at 4. Horizontal would be at 3. So opposite of this number, the outside number. I should do domain and range. Back here, domain is negative infinity to 1, 1 to infinity. And my range was negative infinity to 2, 2 to infinity. Okay. So here when I graph these, I'm going to put my dotted line at 4 and at 3. And this is a -1, so I'm going to put them in the negative quadrants right there. So we're just going to follow along right here. So my domain would exclude the 4. My range excludes the 3. All right, so why don't you try 3 and 4 on your own, and then unpause the video and come check your work when you're done. But make sure you try it on your own first. So hopefully you've gone ahead and tried this on your own. So the bottom makes 0 at -3. There's no outside number, so it's just the rules from before. The bottom's bigger, so we get 0. Negative right here. So we put them in the negative quadrants. So this one, there's nothing to add or subtract down here, so you get 0. Outside number is your horizontal, so it's 2. Three is positive, so it goes into the positive quadrants. Right there. So my domain here is negative infinity to 0, 0 to infinity. This one was negative infinity to -3. And the range was negative infinity to 0. All right, so down here, this follows the rules from yesterday exactly, where we're going to say set the bottom equal to 0 and solve it. That's what this little crazy d over c is saying. And then the y a over c is just like dividing your coefficients. That's what we said yesterday. Same exponent, you divide your coefficients. So that has not changed. And then we're just going to say that to figure out what quadrant, we're going to pick a point. For right now, I'm going to teach you how to find like the x and y intercepts. And then once you have those, you won't need to pick a point. But for now, we're just going to pick a point. So we're going to say the bottom equals 0 at -1. Horizontal becomes 1/3. So when I plot those, so then if I plug in like 0, zeros, obviously in this quadrant down here, let's see what I'm plugging 0, what do we get out? So you plug in 0, you get -2/3. So 0, so when x is 0, y is -2/3. That tells me that they're going to be in this diagonal because it's still in either these diagonals or these diagonals. So if the dot's down here, it goes this way and this way. And I'm not going to do domain and range. I think we did enough above. So vertical, set your bottom equal to 0. Horizontal, divide your coefficients. So this becomes 4/2. So that's 2. This is 1/2. I'm going to plug in a 0 again because I'm pretty lazy and 0 is the easiest number to plug in. So when x is 0, y is -1/4. So, and it's going to be in these two quadrants this time because that's where the dot is. So you try 3 and 4 on your own. Pause the video when you're ready to check your answers. You better have paused the video. All right, hopefully you're coming back to check your answers now to make sure you got it right. So set the bottom equal to 0 here, I get -1/3. Divide, I get 2/3. Set the bottom equal to 0 here, I get -3/4. Divide, I get 1/4. Plug in 0, I get -2/1. So when x is 0, y is -2/1. So that puts them in these two quadrants here because that's where the dot is. So 0 gives you 0. So again, it's in these quadrants.